Welcome back to the Chemistry 1220 Midterm 2 review problems. We are in Chapter 16. And we are talking about acid-base equilibria. So acids and bases is a very large part of Chemistry 1220, and one that you should spend a lot of time studying and reviewing. This chapter will contain most of the math on your midterm. So it is wise, if you are somebody who is not the best at math, it is wise to pay close attention to this chapter and the problem-solving skills that it goes over. So we start out with a problem. Calculate the concentration of an aqueous solution of sodium hydroxide that is a pH of 11.50. So let's first consider what happens when we put an aqueous solution, or when we have NaOH and we drop it into aqueous solution. So the equation for that will be NaOH dissociating to Na plus OH minus. Both of these aqueous. So because we know that the OH minus is going to be completely dissociated, we need to also consider what pH means. So pH is going to equal the negative log of the H plus concentration. We also know that the H plus concentration times the OH minus concentration equals 10 to the negative 14th. That's a constant. Okay. So we also know that pH plus pOH equals 14. These are the core relationships that you should memorize. So pOH is going to equal the negative log of the hydroxide concentration. So taking the negative log, we'll start somewhere else. Taking 14 minus 11.50 will give us 2.5. This equals the pOH. Now remember to undo negative log. Again, this is the negative log of the OH minus concentration. Remember to undo log, you take 10 to that power. So 10 to the negative 2.5 will give us 3.16 times 10 to the negative third molar. And that will be the molarity of the NaOH that's in solution. Because again, if you were to do the 10 to the negative pH, so 10 to the negative 11.5, you would actually be calculating the concentration of hydrogen plus ions, which again would be very, very small, because we are told that we have a basic solution containing a strong base, so you would probably expect the concentration of hydrogen ions to be almost zero, practically for our purposes 0. And let's double check that. So if we did 10 to the negative 11.5, okay, so this is the previous problem. If we did 10 to the negative 11.5, that would give us 3.16 times 10 to the negative 12th, which is extremely small. So we have essentially no hydrogen ion concentration. The next problem is calculate the pH of 0.0167 molar nitric acid, HNO3. So the first observation is that this is a strong acid. You should have that memorized. Thus, it will fully dissociate. in water. Okay? So, we write our expression. And we know that this will fully dissociate. Do you note the one-sided arrow? It will fully dissociate. Thus, if we start with 0.0167 molar of our acid, we're going to get the exact same molar for every species in solution. Thus, this is our concentration, our hydrogen ion concentration. So to find the pH, simply take the negative log of that number. And taking the negative log of 0.0167 will yield 1.78, and that will equal the pH. 1.78. Pretty straightforward. Thanks. See you in the next video.